Okay, bismillahirrahmanirrahim. Assalamualaikum and hi. So, I'm Haris Murshidi bin Maisa. So, today I would like to present about chapter 1, DC Transient Analysis in course Electrical Circuit 2, EEE 231. So next, what is DC Transient Analysis? DC Transient Analysis, also called as time domain, and it is natural response of the system to change from the equilibrium. DC Transient Analysis is one of the ways to investigate the behavior of current and also voltage when energy is either released or acquired by inductor and also capacitor. So this occurred due to the fact that inductor and capacitor have the capability of storing energy. So next, in DC transient analysis have two type of response, which is natural response and also step response. So natural response is happen when the inductor or capacitor is suddenly disconnected from its DC source with no other external excitation. This means no source, with either current or also voltage. So step response is happen when there is an application of DC voltage or current source to the circuit. So like we can see on the screen now, natural response is until step 3, and for step response is until step 4. So what is step 3 and what is step 4 after this? So in this chapter have two type of circuit, which is RC circuit and also RL circuit. Okay, so for RC circuit, which is we have 4 step, which is step 1 until step 4. So step 1, at t is less than 0, that means t is equal to 0 negative. So what is the step? We need to identify the switch first, and then the capacitor will open circuit, and we need to find the VC 0 negative at step 1. So next, we move to step 2. In step 2, t is equal to 0. That means t is equal to 0 positive. So we need to identify switch. Capacitor will begin to release energy. Therefore, the voltage in capacitor will remain same. Therefore, VC 0 negative is same with VC 0 positive. Step 3, when t is more than 0, that means t is equal to 0 positive. So the first, we need to identify the switch and then find time constant. And then in this part, if circuit does not have any source, either voltage or current, just proceed to the general equation of natural response, which is this is the equation of VCT when no source at step 3. If there is a source, either current or voltage, we continue until step 4, which is t equal to infinity. So first we need to identify switch, open circuit capacitor, and we need to find VC infinity. Then after we get VC infinity, just proceed to generate the general equation of step response. So next, for RL circuit, it just same with RC circuit, but inductor will short circuit. Difference to RC circuit, which is capacitor will open circuit. So let's go to the question, which is RC circuit. So question 1, the switch has been at position A for a long time. At t is equal to 0, the switch is moved to position B. So there is two things that we need to find in this question, which is find the expression of VCT and IXT. And the second one, we need to construct the table and sketch the graph. Let's follow step by step. So let's see the step number 1. At t is less than 0, which is t is equal to 0 negative. So the first thing we need to find is identify the switch. From this question, switch at position A at this step, and we need to identify that capacitor will open circuit. Then we need to find VC 0 negative at open circuit capacitor. So from this question, when the switch at position A, this 8 ohm and 12 ampere are not on, and we just neglect these two components, and the component will become like this circuit. We have 2 ohm, 8 ohm, and also 8 volts. So how to find VC0 negative at this open circuit capacitor? So like in this case, I use source transformation, which is with this 8 volts and also this 8 ohms. So after I use the source transformation, the circuit will become like this. We have 1 ampere here and also parallel with this 8 ohms. So how to find this current 1 ampere? Just by using Ohm's law, V is equal to IR. So in this case, we need to find the value of I, current. Therefore, I is equal to V over R. So 8 over 8 will become 1 ampere. So first, we need to find the value of R equivalent first before we proceed to find the VC0 negative. So in this circuit, to find R equivalent is at here at the open circuit capacitor, which is 2 ohms is parallel with 8 ohms, and the value will become 1.6 ohm. So to find VC0 negative, just by using Ohm's law, V is equal to IR. So the current I is equal to 1 ampere, and the value of resistor, the R equivalent, is 1.6. Therefore, VC0 negative is equal to 1.6 volts. Next, let's go to step number 2. T is equal to 0 positive. So the first thing, we need to identify the switch. So at this point, at this step, switch move from A to B. Therefore, capacitor will begin to release energy, and the voltage in capacitor will remain same. Then VC0 negative is equal to VC0 positive is equal to 1.6 volts. So next, let's go to the next step, step number 3. Step number 3, T is more than 0, which is T is equal to 0 positive. First thing, identify switch. At this step, switch starting to move to B, switch at position B. So after we identify the switch, we need to find the time constant, which is T is equal to RC. If this is RL circuit, inductor circuit, the formula is T equal to L over R. So in this case, to find time constant, T is equal to RC. We need to identify the value of R equivalent. Let's see to the circuit at the equation. When the switch move at position B, this 8 volt is not on, and we just neglect this component. And the component is only this one, like in this circuit. So to find the value of R equivalent, we need to remove any current source or voltage source. So in this circuit, we have current source, and when we remove the current source, the circuit will become open circuit. So when we open circuit this 12 ampere, this 8 ohm resistor will not on, and we just neglect these two resistor. And the only one resistor in the circuit is only 2 ohm, and R equivalent is equal to 2 ohm. Therefore, the value of time constant is equal to 2 ohm times 4 millifarad is equal to 8 millifarad, the value of time constant. So next, we need to check either the circuit have any current source or have any voltage source. So in this question, we still have current source here. So we need to proceed until step 4, which is go to the step response. So step 4, at T is equal to infinity. So like normally, we need to identify the switch. So in this step, switch at position B, and then open circuit capacitor. So after we open circuit the capacitor, find VC infinity at that open circuit capacitor. And to be more easier to understand this circuit, I move this 2 ohm at here, which is like in this circuit. So it is more easier to understand this circuit. And then we just need to find the VC infinity at here. Before that, what we must to do? So to find the VC infinity, the voltage, the VC infinity at this 2 ohm resistor, and we just need to use Ohm's law in this case. So this circuit, I already series these two resistor, 8 ohm and 8 ohm, and the resistor will come 16 ohm. And then just by using Ohm's law, V is equal to IR. VC infinity is equal to 12 ampere times 2 ohm. So how about the 16 ohm resistor? So the basic in electrical circuit, current will remain same in series circuit. So just by using Ohm's law, 12 ampere times with 2 ohm, VC infinity is equal to 24 volt. And then we just proceed to the general equation of step response, which is VCT is equal to VC infinity plus VC0 minus VC infinity exponent negative t over time constant. So after I enter all the value, the equation is VCT is equal to 24 minus 22.4 exponent negative 125t. So we have done to find VCT. Next, we need to find IXT. So to find IXT, we can just use Ohm's law, which is V is equal to IR. Therefore, I is equal to V over R. So in this question, in this case, IXT is equal to VCT over 2. So after I enter the value of VCT, IXT is equal to 12 minus 11.2 exponent negative 125t ampere. So let's go to the next question, which is we need to construct the table and sketch the graph of VCT and IXT for t is equal to 0 until t is equal to 5 tau. So to construct the table of VCT, we just use the previous equation and we just use calculator to enter the value of tau, which is 0 until 5. So by using this equation, VCT equal to 24 minus 22.4 E negative tau, and we just enter the value of tau by using calculator. So next, how to sketch the graph of this table? So by using this table, we just sketch the graph, which is like this one. We just make VCT versus tau here, and we just enter the value from the table. Okay, so next, let's proceed to construct the table of IXT and sketch the graph of IXT. So we need to construct the table of IXT. The same procedure, the same steps, we just use the previous equation, and just by using calculator and using this equation, IXT equal to 12 minus 11.2 exponent negative tau, and we just enter the value of tau, which is 0 until 5, can obtain the value of IXT. So from this table, we can see the graph will increase, same like the graph of VCT, and the graph will become like this, which is when tau is equal to 0 until 5 tau. So just that from me. But before that, the important things in this chapter contain two circuit, which is RC circuit and also RL circuit. So the difference between these two circuit is capacitor will open circuit and inductor will short circuit, and the difference is in the equation. And the last one, when we want to sketch the graph, be careful of the sign of negative. So if the value of IXT is negative, the graph will become the negative side. So just that from me. Thank you. I'm Haris. Assalamualaikum.